Okay. Plesiosaurs and pliosaurs. We met Mary Annie briefly earlier. She's kind of had a renaissance in the last 20 years. She disappeared for about 100 years, but she was a fossil collector and on that south coast of England. And she collected very early, near complete specimen of a plesiosaur. And it was a big deal because it was the first plesiosaur from England. And the Germans had one, the French had one, the Italians had one. Now the English had one, and people were very excited. And if you go to the Natural History Museum in London, you'll see her plesiosaur, and she's back up next to it. For 100 years she was missing. But there she is. She was not a paleontologist. She was a really skilled fossil collector, and actually fairly well respected by people who collected fossils. That's kind of neat. So, other random things. The Loch Ness Monster is often, as I said, presented as a plesiosaur that didn't go extinct, and has all sorts of grainy photographs like this and footprints in the mud, things like that. That's the Loch Ness. It's very deep, very long loch. You know, it's a lake, but it's a very deep and very long and very murky. So there might be things hiding in there, but there's not plesiosaurs hiding there. Almost certainly not. No one would be more excited in the biology community to have it. But think about it for a minute. You can't have just one, unless it's the last one. I mean, there has to be a population of them, and that makes it even more, as big as it is, makes it even more unlikely it's hiding there. But like I said, no one would be more excited than the biologists. Look at this thing. A Japanese fishing trawler was off the coast of New Zealand in 1977, and they came across this thing floating in the ocean. They pulled up, took some particularly good pictures of it, and then since it was rotting, they threw it overboard. I think they took a couple samples of tissue from it. And it made the rounds in the late 70s because it was thought to be a Sarcopterygian, a plesiosaur, and that's the captain's drawing of it. And you know, he's embellishing it a little to make it look like a plesiosaur, and it still shows up on websites in the nonsense that passes for science, sometimes in popular culture. You'll still see this presented. There it is. Another picture of it. And it's not clear, it wasn't clear to me when I first saw it, but people who work in marine biology looked at it and were pretty sure right away what it was. What it is a basking shark. That's a basking shark. It's a very large animal. It's a filter-feeding shark. And if you look at what they had in a basking shark, it's fairly obvious what look like limbs are just fins. There they are there. And it looks like it has a small head because the gill arches have rotted and fallen off. And the dorsal fin is missing, and the caudal fin is missing, the tail is missing. So as cool as it would be if it were a plesiosaur, it's not a basking shark. And I think they say to plug a tissue on it and it has basking shark DNA in it. So whenever that's put forward, well, if you're one of those people who believes that the media is always lying to you, then I suppose you still believe this, but been debunked. Again, no one would be more excited than the scientific community, but we just look at things more skeptically than your average Fox News viewer. And there's stuff like this. Oh, there's a plesiosaur, a pliosaur washed ashore in Africa. Look at that clear picture one, right?
It's photoshopped.
Yeah, it's photoshopped. It's another basking shark. It's just been photoshopped. And nowadays, photos are a little bit more easy to fake convincingly than they were 50 years ago. Lastly, well, penultimately, second to last, we have ichthyosaurs. That means fish lizard. These guys were awesome. Rapid swimmers in those Mesozoic oceans, fully adapted into aquatic life. Think dolphin niche. And as I said earlier, their placement is unclear. They are so highly specialized into that swimming niche that the parts of the skull we want to look at, other clues we need to help determine where they go, have just been either lost or modified into swimming specializations. So, for example, they've got that weird Euryapsid skull, which they share with the plesiosaurs, but it's not thought to be a link. just an accident of evolution. So anyway, there's someone actually drawing them like dolphins. Anyway, I already said that. Clues to relationship is good. When they would collect fossils of these, the vertebrae, the backbone goes into the lower lobe of the tail. It's unusual. Usually you see it like sharks goes lobe. And so the fossils always show up like this. And the early people who would collect these would want to display them, and they would always break that little joint there and straighten the tail because it looked right that way. They thought that looked wrong. I think that, until someone finally got a fossil where it shows the tail imprint. So, yeah, there's a diversity of them, and we have enough specimens that we can map out a phylogeny with lots of different groups, families, which we're not going to worry about here. They appear to go back to the Triassic. That's pretty bold. And here's a candidate for an early one. Again, a creature kind of like an otter or a seal. It's in water, out of water. And there's the skeleton, and there's a reconstruction of this creature. In their forelimbs and their hind limbs too, highly modified into flippers. We don't see any hint of fingers anymore for weight bearing. And we don't have the transitional fossil that shows that. We got this little guy, but he didn't give us a whole lot to look at. So there's hypothesis of some relationships there, you know, an evolutionary tree based on flipper anatomy. Size range, I like big and small. There were some really large ones, whale-sized, and there were some, pet-sized ones for your big aquarium.
Would those be adults or juveniles?
That's always the question. That's adults or juveniles. Sometimes, and this question was, are these adults or juveniles? Is this just a juvenile of this, or is that an adult? You can look at the skull, you can look at bone structures, and there are clues that give you an idea whether it's an adult or a juvenile. So I would assume that they worked through that. Juvenile skulls, the bones tend to be loose and not connected. In adults, they're fused together. So that's probably what they're looking at there. But it's always a challenge you face when you're looking at a bone. Is this just a baby, or is it something that small? That's just a great picture of what they might have looked like. Another one, I just left these pictures. Here's another example of an exquisitely preserved fossil suggesting live bearing that appears to be an embryo. Either she swallowed that whole, or it's a baby. So they appear to have been live bearing, which makes sense because they're not coming out of water to lay their eggs, because they don't come out of water. They don't have tools for coming out of water. Although now, having said that, sea turtles come out of water, don't they? And they don't look like they'd be good at it. So maybe they could have been like sea turtles, I suppose. But there's a painting of one live bearing. And like whales, they have to breathe air, so when they come out, I can see the mom pushing them to the surface to take their first breath of air, just like a whale mom does. What they eat? Well, that's a fish gathering tool, but again, those early oceans were filled with ammonites. That's an ammonite, and that was probably a big part of their diet as well. And this is a beautiful fossil here of a full ichthyosaur skeleton with what probably was a major part of its food, the ammonites. And this great one shows that bend in the vert backbone and the imprint of the tail. They, like I said, probably did not come out of water, but there's an early idea of one coming out of water. Can't remember why that picture's there. There's an example of where the person who did the research broke the tail and straightened it out because he thought it should have a straight tail. But that's the reality. There it is. You can see the tail right there. So they disappeared before dinosaurs disappeared. They disappeared from fossil record about 30 million years before dinosaurs did. A nice example in these guys of convergent evolution. Remember, convergent evolution is two different things adapting to a similar niche, becoming similar in their anatomy. And I keep saying dolphins, there you go. Dolphins and ichthyosaurs, probably a very similar niche between the two, chasing down fish and squids for a living. Chasing down small prey for a living, the shape of the body on an ichthyosaurus, we interpret it in a tuna. All right, one last group, mosasaurs. That's from the early fossils are found near the Meuse River in Germany, and Mosa, I guess, is Latin for Meuse, so river lizard or Meuse river lizard. And they are closely related to Lepidopteran. In fact, they are Lepidopteran. They're well, more closely appear to monitor lizards, which are closely related to snakes. They're a little more closely to snakes than they are to lizards. So there. Remember our evolutionary tree there over here with the monitors, like Komodo dragon, an aquatic Komodo dragon. Okay, there we go. There's the modern version. And they have a classic diapsid skull. No problem with that. Yeah, it's broken. This one's broken, but there's our openings there. The monitor lizard up there. We stopped at a fossil shop in Quartzsite, Arizona, and my daughter bought what is supposedly a mosasaur tooth, and an awful lot of them there. I'm wondering if they faked them or not, but I didn't. She's pretty proud of it, so I didn't say that might be fake. So anyway, there you go. This is a neat little piece of joining together someone saw. They found an ammonite shell with these very regularly placed teeth marks, and they matched up with the spacing and the arrangement of teeth in a mosasaur. A little bit of clue as to what was going on back then in those oceans. So, size range, we got, again, nice range of sizes from pet-sized to easily swallow-you-sized. Okay. Did that. Okay, let me skip some of this. I'm going to do one more thing here. End of all this Mesozoic stuff, except for the theropods, which are still with us in the form of birds. Here's the end. Here's the end of the Cretaceous is defined by this big extinction event, and the other side of the extinction event is the Tertiary. That's the point. And something happened on our planet, and a huge portion of wildlife and plants and things went extinct. And it's thought to have been a comet or a meteor strike. And among the things that survived are mammals and theropod dinosaurs, the bird group. So there's the Cretaceous, and there's the Tertiary. So we're talking about the extinction event there. And we had just a really, really bad day on our planet when nearly everything went extinct. And there are different hypotheses of what happened that day. There's that one that we've used before. And there's the other one. And there's another Noah's Ark themed one. But the current hypothesis is that it was a meteor strike or a comet strike. We had these cool Cretaceous habitats and everyone running around chasing everyone else, and boom. This body struck the Earth and threw so much debris in the atmosphere that the sun was choked out for a period of time. The plant life would have died. There would have been fires everywhere, and many large things didn't survive. Many aquatic things didn't survive. The site for the strike is in Yucatan and right in here, and there is a very ancient crater, evidence of a crater there. And if you look, you can find evidence of the ejecta being thrown out, the molten material that flies out and lands as glass. So there are geologic evidence for this particular strike, and that's thought to be the one that did. The time is right, the size is right. So there's just the immediate damage of this particular strike, but the real damage was throwing all this debris in the atmosphere and choking off the sun for a period of time. anyone nearby would have been in pretty sad shape. And this is where it is. This is Mesozoic Cretaceous. This is Cenozoic Tertiary, and that's the joint. Right between them, if you put your finger on that, that was the surface of the Earth when that particular object hit. And one of the things that is evidence of that is that all over the planet, right at this juncture between Mesozoic and Cenozoic, right at the joint there, is this layer, and there's a lot of iridium in it. And iridium is a fairly rare element in the Earth's crust, but it does show up in meteorites. So that's thought to have been, the iridium there is thought to have been brought in on that meteor. And so there it is right there. You know how to look for it. I'm sure Chris Wheeler does, I don't. You can find it. Because again, I found lots of pictures of it, obviously. And you can buy pieces of it on eBay. These are these little glass fragments that were thrown up in the atmosphere when that meteor hit. Someone's selling them. Someone in the United Kingdom. Anyway, as we close out, dinosaurs connect us to the past, and they're vertebrates, which is why we talked about them. There's a universal fascination on these creatures, and what I hope to do is, what I hoped I was doing is walking through this, is we talk about evolution, we talk about diversity, which is what this class is about. We take these creatures that we're not extremely familiar with because they're not birds or mammals or lizards, and we can apply ecology to them. We can take what we know about mammals and birds and lizards, and we can form hypotheses about these ancient creatures. And I think that's a useful exercise. And like I said, they fascinate us to this day. Anyone been to the Naturalist Museum in London? That's the Naturalist Museum in London. When it was built in the 1840s, it was built to look like a cathedral, a huge church, because it was supposed to be a place where we go worship nature, or we go appreciate the gift of creation. So it actually has a very Gothic cathedral look to it. Okay, I'm going to go set up our lab. Let's call it day here, and we will start birds on Wednesday. I think I put the bird PowerPoint up. I will circle the PowerPoint around a fair amount, so I'll remember to load a fresh bird version.